Hello and welcome everyone. A bit introduction of what is going on this stream series. I will go through this course. I will be watching videos, reading papers of CS6120 Advanced Compilers course by Arei and Samson. The goals of learning this course, of studying this course, is to become famous and have an excuse for over-engineering the software systems I work on. That's basically the primary reasons. And the reasons for the stream series is not actually share my expertise, knowledge, opinion or view on this stuff, but basically to be consistent with this thing. I will be using a timer, focusing a small amount of time on the course, watching a video or reading a paper or writing a notes on all of those things. And during short periods of times we'll try to answer some comments if anybody comes and post those comments, and repeat it a few times until I get tired. And after I get tired, I just finish the stream, say goodbye to everyone and keep doing my usual stuff and probably some other work or maybe sports activities or whatever. So that's basically it, and I guess I will start a timer. I already started watching the video, so if you are interested in the first part, just go to this link. I put it into the description of the stream and see what was first 6 minutes of this video was about. But right now I will keep watching and writing down my notes on this first introductory video.
Is that there is a rapid expansion in the number of programming languages that people want to write and the number of different kinds of hardware that people want to target to. That is about the expansion in programming languages. It's not just about general purpose languages. If you've ever used R, for example, or if you've ever used TensorFlow, these things all sort of count as domain-specific languages for one purpose or another that people actually want to get good performance out of. And it's not just limited to one or two high-profile examples. I believe that domain-specific languages are really proliferating because they're found to be a better way to match the semantics of how people think when they want to express programs to computers. And at the same time, because of the end of Moore's law, the diversity in hardware targets is also in the middle of expanding. You may know, for example, about Google's TPU being deployed in their data centers for running machine learning workloads, but there's also, just in everyone's cell phone, dozens and dozens of specialized hardware units that just do one particular thing very well. We're kind of running into this n times m scaling problem, where the number of programming languages that people want to compile is expanding very rapidly, that's n, and the number of hardware targets that people want to compile to, that's m, is also expanding very rapidly. So either of those two things by itself would mean that we have a great need for new compilers to compile new languages to hardware. But the fact that they are both expanding at the same time means that that's a multiplicative effect, and there's a huge demand for new compilers that do new kinds of optimizations for new kinds of hardware and new kinds of domain-specific semantics. Just as an anecdote, I think it's almost a cliche at this point when you go to computer architecture conferences. I spend half my time as a computer architect. That people are building lots of hardware that they find super interesting and can do one or two things extremely well. Novel hardware is super exciting for individual applications, but nobody knows how to write compilers that unlock the full potential of those domain-specific hardware accelerators. Specialized hardware is not actually something that anyone wants if it's too narrowly targeted, and if people, as is the dominant trend in computer architecture conferences, if grad students have to manually write assembly code for every new accelerator they develop, for every application they want to compile to it. The problem is that we don't know that the science of compilers is not advanced yet. The science of language implementation has not caught up with the massive explosion of domain-specific languages and novel hardware targets. All of this together means that it's an extremely important time to be focusing on compiler research and to focus beyond just the classic but very important notion of just optimizing programs but to take into account all the other things that we want to get out of the language implementation, including correctness and security and debuggability. All of these things matter. All these things matter, and all of them are surprisingly hard to do, and we're going to need to do them many times over if we're going to capitalize on this explosion of diversity in both languages and hardware targets. That concludes my excitable motivation about why we're studying compilers and language implementation more broadly in 6120. I want to now take you to the syllabus to talk about how this class is going to work. And I have to give the qualifier that in general, I have no idea how this class is going to work. Relative to other semesters, this is a time of incredible uncertainty, and we will just have to see how this goes. I'm going to give you my best guess about how things are going to run for this fall, but I ask you for your patience to bear with me while we figure it out on the fly. On the 6120 website, there's a tab at the top of the syllabus, and we're going to go through a few of the details right now. One thing we've already seen is that we're using this chat tool called Zulip, which is a kind of like weird open source Slack-like thing that has a few cool features that I think will make it exciting to try for 6120. Again, thanks for bearing with me while we try this out. We're going to do all the communication through Zulip, so it's really important that you sign up for it and that you pay attention to it. We're going to do a lot of required discussion participation that happens on Zulip. So you need to familiarize yourself with it and to actually participate when it comes time. There's a bunch of links to Zulip. There's apps for all the platforms you can get, and they are perfectly fine. The iOS one is actually sort of garbage, but that's neither here nor there. And there are also links throughout the webpage that go to individual threads of conversation called topics in Zulip that we'll be using. And you can just use Zulip right from your browser as well. Okay, so let's talk about what is happening in the actual class section. So nominally this class is 9:55 to 10 something, 9:55 to 11 something rather on Mondays and Wednesdays. But most of the actual stuff that we're doing will be asynchronous. In particular, I want to try out to deal with the complexity of like hybrid in-person virtual scheduling. I'm interested in most of our class sessions being flipped in the sense that you'll be watching videos and reading materials offline, like you're doing right now with this video, and then the actual class sessions, the majority of them will be kind of quiet work times, and you can come and hang out in person, hopefully outside some of the time, and hack and ask questions on Zulip if you are in Ithaca, and if you're remote, then you can join those things by hanging out on Zulip and silently hacking and asking questions and participate just as much as anybody else, because everything will be sort of coordinated around our funky chat system. But in general, these classes will be divided slightly more granularly than that. If you look at the schedule is a tab at the top of the webpage as well. You will see that there are sort of two types of classes. The first one, which is today, is that the class has lesson content in it. And this has a link to a particular lesson that we'll have a video once it's done being recorded, and there's some notes, and there's some tasks to complete. More on this in a second. But you can, before these classes, do the optional reading associated with them and watch the video. And then when we show up, we'll just be doing sort of silent work time in the flipped classroom style on the tasks associated with the given lesson. On some other days, there will be a discussion to be had. So there's some reading material that is not optional, but is actually required to do ahead of time. The first one will be on Monday. And the difference with these is that we will not have any in-person content. And the reason for this is that we're going to have a discussion, a live discussion on Zoom. So I just cannot even fathom how it would work to have a productive discussion where some people are in person and some people are remote on Zoom. That just seems like totally unworkable to me. So for those days, for the discussion days, those things are going to be all virtual. They're going to be all on Zoom. So please join at the appointed time synchronously for a short discussion that the leader for a given paper will be conducting. It's not going to take the entire class time. The rest of it is going to go back to the sort of flipped classroom work time, but we will have a chance to sort of follow up on the discussion that happened asynchronously over Zulip in the days leading up to the class. So just to summarize, when you are participating in this class, it's important you go to the schedule every so often and look at the upcoming days and see whether they are discussion days, in which case we're going to actually have a discussion, and you have homework to do beforehand and the homework you have to do beforehand is reading and participating in discussion on Zulip, or they are lesson days, in which case your homework is to watch the videos and to do the optional reading, but the actual work that we'll be doing will be starting in class so that everyone's working together can ask each other questions. I hope that makes sense. So the next thing to talk about from the syllabus is the actual work that will go into the class. There are 4 things that you have to do of various shapes and sizes. The first one is smaller implementation tasks that are associated with the lesson. So they're meant to kind of follow up on the things that you'll learn in a video like this, and they're sort of smallish self-contained tasks that are still nonetheless have some interpretation to them that you complete on a fairly short turnaround. So most of the deadlines are about a week away for these things. There are tasks associated with this lesson, which I'll get to at the end. They are no big deal, but they are due in a week. The next thing that you have to do, that you'll be graded on, is reading the research papers and participating in discussion. So participate in the discussion asynchronously on Zulip, and then when it comes time for synchronous discussion, if you're participating synchronously, participate by talking on Zoom. For one paper, I think, for the entire semester, you will be leading that discussion. So your job is to read the paper ahead of time and to lead the discussion by doing the following things: writing a blog post, which can come with an optional video if you want, leading the online discussion on Zulip ahead of time. That means coming up with discussion questions and getting people to actually answer them and engage. And then finally, leading the synchronous discussion that happens on Zoom. So you'll do this one time throughout the entire semester. The rest of the time, you're just a participant. Then finally, there's a course project. So at the end, in addition, this is totally separate from the sort of smaller implementation tasks. The course project is a kind of entirely open-ended, kind of do whatever you want that's related to compilers thing. And there's details about that later. Okay, so everyone, let's talk a little bit more about these implementation tasks. The tasks for lesson 1 are fairly straightforward. There are 4 of them. They are not complicated. They're just meant to get you familiar with things and to get you to do a couple of kind of class warm-up things. The first thing you need to do is actually read the syllabus. You're getting some information now, but I would really appreciate it if you were to read all the actual details there. The second is to sign up for Zulip and to introduce yourself. So this links to the introductions topic on Zulip that you can follow right there and just write a couple of sentences about yourself. You can see my prompt at the top. the next thing you need to do is pick a paper from the class schedule that you will lead the discussion of. So if you follow this to the schedule, you'll see that there are lots of papers that say a TK next to them. So for a given day, someone is supposed to be leading this, but we don't know who. If you go to this link, you'll be led to the GitHub repository for this course. I didn't mention before, but this course is entirely open source. Everything is on GitHub that you can possibly imagine. This is the repository on GitHub. This is my username, and this is the repository. And everything that runs the website, which is everything that runs the course, is open source in this repository. So that includes this funky file that lists everything we're going to be doing on every day, on every class day. So for example, this is a class day where we'll be reading a paper by Lopez et al. About automatically verifying a domain-specific language for specifying people optimizations. It's a really sweet paper, so somebody needs to lead this. Your job is to open a pull request to put your name in right here. That is to claim one paper throughout the entire semester. You can fork this repository. You can use GitHub's in-browser editor thingy to add your name, but please do that as part of the tasks. The last task is to tell me that you did it, and this is true of all tasks associated with lessons. You'll log into CMS and find the appropriate task. This one is the L1 intro tasks, and you just need to basically input a marker to say that you did the thing. So this thing is not really anything to turn in. CMS doesn't let me have nothing to turn in, so you can just submit like an empty text file. There's like a text file submission thing. You just need to like submit something just to say that you've done it. For every other one, I encourage you, I don't require you, but I encourage you to do all your work as open source. So just like the rest of this course, you'll make like a GitHub repository or a Bitbucket repository if you're into that kind of thing, and you'll do all your work there, and the thing you'll submit is just the URL to that repository to say that I have done this thing. You don't need to submit any code there unless you strenuously object to having your work be open source, in which case you can upload your source code instead. But I really do strongly encourage you to do everything open source. This class is really meant to run on the honor system. That is, that like the tasks are meant to deepen your understanding by going through the motions of actually doing something, actually seeing it through all the way to the end, and struggling with the hard problems yourself, as opposed to just looking up the solution that someone else had. So please do everything open source, and please use your own judgment, and don't look at other people's implementations unless you totally want to cheat yourself out of the opportunity to struggle with things and figure out yourself, and therefore actually deepen your understanding of the topics in the course. So there's the implementation tasks. One thing I didn't mention is that you're allowed to work in groups if you want to. You can work in groups of 2 or 3 students if you like. You can also work individually. Totally up to you. CMS will let you form groups if you want. The next ingredient is this discussion stuff. So as I said many times before, for the discussion classes, ahead of time you need to read the paper and you need to participate in the Zulip discussion. Where does the Zulip discussion come from? That comes from the discussion leader. For the first discussion, that's going to be me, so you can see how this goes. The things that you need to do include writing a blog post. I have advice here about what exactly needs to go into a blog post that gives sort of your critical reaction to what's going on in the paper. This is not meant to be just a summary. This is meant to be your opinion about what's going on in the paper. You can, if you like, record a video to go along with your blog post. You don't have to do this, but just in case you want to participate in the 2020 style of education, go for it. You will use a pull request to publish your posts to the GitHub repository. That will automatically make it live and go on the internet. I will review it and probably have feedback for you during the pull request process. All of that is, you also need to, once your pull request is open, so that even before I necessarily give you feedback, you have to announce it on Zulip. That is, you have to like give people a chance to read your work before it's even ready, and to possibly give you feedback. I will definitely give you feedback, but other people are welcome to as well. All of that stuff is due 1 week before the class that actually has the discussion in it, so that we can have a week of discussion. So as part of your discussion, as part of your blog post, you will have some bulleted questions that you have discussion questions to get things started, and you will post those into the Zulip thread where you announce your pull request in your brand new blog post, and you'll get people to engage on those questions. Everybody else is required to participate in that discussion. That is, they're required to read the paper and say something, who cares, something in response to it, possibly in response to your discussion questions that you came up with. Then finally, on the actual day of the discussion on Zoom, and again, this is one that does not happen at all in person, it's only on Zoom, you will moderate the discussion on that thing. Don't prepare a presentation. That is, like, don't go through a bunch of slides. You can have a visual aid if you want, just to like sort of organize the discussion. But the point is, you don't need to summarize stuff for people that will already have read it. You just need to be doing the kind of the live version of what you did for your blog post. That is, giving your reaction to it, giving trying to bring a critical lens to the paper that you brought, and to get everyone to participate. It is your job to get everybody to speak up and to participate as equitably as possible. Okay, so those are discussions, both participating in and leading. So the final thing is a project. I'm not going to go into a lot of details. You can learn about the project online. It's going to be a totally standard course project that is open-ended. You can do whatever you want that is related to compilers. You can build on the implementation tasks you did during the semester, do something totally different, do something connected to your research, whatever. You can see the details here. Deadlines you can find on the schedule as well. There is going to be a blog post at the end of the project. So for all of this stuff, we're going to be using a grading system that we started using last year with the first offering of 6120, which is the Michelin star system. That is, if you do a really excellent job that is astonishing in its breadth and depth, you get a Michelin star. It's meant to recall that like even a single Michelin star in the Michelin Guide is a remarkable achievement. So if you do a remarkable job and you turn in something that you're proud of, you get a Michelin star for that assignment. It is possible to earn multiple Michelin stars by being truly exceptional. It's possible to get not a star if your work is merely okay. And that's fine too. You can turn in really acceptable work from time to time. That's cool. Doesn't like who really cares about grades? The Michelin stars will turn into the final course grades. If you consistently get a Michelin star, that means an A. If you consistently get if you consistently miss Michelin stars, then that will slowly reduce the grade that you get. The Michelin star system is meant to get us out of the business of grubbing about individual points and scores, which I think is wholly inappropriate for this like open source hacking oriented class that we're going to do for 6120. Instead, it's meant to focus on what really matters, which is doing a great job and being proud yourself of what you turn in. A final few note on a few policies. So the first thing is that this is a class for PhD students. If you are not a PhD student, it's still possible to take this course, but you need to have special permission to do it. I give you the directions here. You just send me a short application that answers 2 questions. So undergrads who are suitably motivated can still take this course. There are some policies here about academic integrity. I think that you will find them completely unsurprising. The things that you turn in, that is like the stuff that you represent as your work, has to be actually your work. You are, in this class, it's meant to be open source, and the world is open to you to figure out how to do this stuff. You just have to actually do the work yourself. If any of this enters a gray area, just contact me and we will resolve it. I care deeply about respect within the bounds of this classroom, even though it's, for the most part, not even really a classroom. It is super important that everyone participating in the class, because it's meant to be discussion-oriented, be as respectful of each other as possible. This means being careful about your language, for example. One thing that you should absolutely not do is if you are participating in a discussion and you need to bring up a kind of example person, one thing you should not do is try to make up the gender for that person for no particular reason. That is like to assume that the programmer, the notional programmer for a compiler is male, for instance. Don't do that. Just don't use a gender for that person. Just use they or them. In general, be respectful of all identities within this class. If you ever notice a problem with respect within the class, please bring it to me, or you can go over my head to the department chair if it doesn't seem like something that I can deal with. There's also a section about special needs and wellness. I want this class to be accessible to everyone. If there are any particular things that this class can do or that I can do to make this class accessible to you, please feel free to let me know. Please also feel free to go through the Student Disability Services office to get an official determination, but I'm also happy just to chat about it. Just send me a message on Zoom. So that's about it. This is the first video I've ever recorded for a class, pre-recorded as part of the course materials. So thanks for bearing with me, I guess. Right now would be an excellent time, if you haven't done it already, to follow this link to the introductions topic on Zulip and to introduce yourself. See you next time. Thanks. Hello, and welcome to the first lesson of CS.
Hello, Ash. Hello, Shania. Mess me up with all the brain twisting concepts. I think not today. Today was like only a brief introduction to the course. The only important take from today's lesson is that it doesn't make much sense to focus on the performance in this compiler course, because the performance of LLVM or probably many other compilers increases very slowly with years, and it's just like fractions of percent or just percents per year, so it doesn't make much sense to really invest in it unless you are very interested in the topic of optimizing compilers performance and performance of the programs that compiled by this compiler. The most interesting part of this course for me is that it shows the whole. Oh, actually I need to start the break myself. Very interesting. Okay. The very interesting part of this course for me that it shows you like almost real world compiler, but with a bit simpler intermediate language called Guile, and we probably will implement some parts of the compilers during this course, but what is more interesting that later we can apply the same knowledge that we get during the course for Guile, which also have an intermediate language which is probably simpler than LLVM. It's hard to tell which one is simpler, but probably the Guile's one is simpler. I don't have like any metrics or any expertise to make this claim, but this is my educated guess, I would say. And having all this knowledge from this course, maybe it will be a bit better to improve and implement different fun tooling for the Guile. You probably already know that I'm working on Guile IDE called Arei and Ares, and having more experience with program representation, program optimization, and all that very deep knowledge about compilers may help to implement this tooling in less hacky way and provide some fun functionality. For example, some low-level debugging capabilities, because you know the Guile program is usually a scheme code which compiled into 3EL, which is intermediate representation, which basically just abstract syntax tree of the program, which later lowered into CPS soup, which is continuation passing style intermediate language, and only after that it get compiled to either WebAssembly or virtual machine bytecode. And I think somewhere on the CPS level, CPS soup level, we can do some cool tricks and provide some debugging capabilities to IDE, and maybe something fun will be produced out of it, but maybe not. For now, I just want to become consistent with going through this course and reading the papers and watching videos and solving tasks provided by it. Probably I will be adjusting the tasks for my taste. Maybe I will skip something. Maybe I will do something in a different way than it's expected by the course. But anyway, the primary task is to be consistent with all the stuff happening here. Hello, Alan. Went to climbing gym yesterday. It was awesome. Cool. I was on the rocks in the desert on Saturday. It also was a cool experience. Flashed a few routes, suffered a bit on 7A, but did all the moves. Probably next time when I will be fresh, I will send it. Okay, we actually watched this video. Now I think I will switch to the task sections, which is not very related to me because I don't need all that administrative stuff. I already picked a paper that I would like to lead discussion on. I don't actually know if I will actually lead this discussion on this paper or I will just share my ideas on it, but overall the topic seems at least somehow related to what we do with Guile and somehow related to Guile, so I picked this one. In the schedule you have like a few classes where instead of the lesson on a particular topic, the paper mentioned, and one related paper is Unified Theory of Garbage Collection, which is probably also interesting to read because you know Guile is garbage collected language, and Andy Wingo made a talk on last FOSDEM, probably yesterday, on a VPIT garbage collector he is working on, which probably will produce a better garbage collector for Guile. I didn't watch his talk yet, and I'm not sure how I am interested at the moment in garbage collection. So the paper I'm talking right now about is this one. I also don't know exactly what the paper is about, but at least it looks somehow related and possibly interesting. Formal verification of realistic compiler. Looks hard because you know verification is a whole different topic. One more reason why the compiler's course is interesting, because the configuration approach we use in RD right now, it's features mechanism which built on top of Geeks services mechanism. It's very like simple approach. We have a graph and we have nodes of the graph, and those nodes can extend other nodes, and inside those nodes we have logic encoded which like takes those extensions and produce a value out of them. And of course it's only one way flow of the extension, so the nodes on the bottom can extend nodes above, but you can like have cycles in this graph. You don't have any type inference, you don't have any type checks except some basic runtime checks that can be hard-coded in the record creation constructors, which is not like very helpful. And one of the possible improvements here is to utilize propagator networks. The propagator networks first of all works with cycles in the graph, and if you can build a nice data structure which can have some cycles in it and handle it properly, have type annotations and type inference, you can provide like a more flexible and more convenient mechanism for creating configurations of operating systems and home environments. And I guess the understanding of some low-level details of this course also can help. Actually, we don't have any more stuff to work on today, because lesson 1 is covered, I guess. I already picked a paper that I would like to read and later discuss. I don't need to register anywhere or introduce myself. Oh, I can introduce myself to you, but you probably already know me if you watch it. What else we have? Also, it was a question, the reasons to study compilers. I wrote the only one reason is to provide an infrastructure for easier runtime introspection of the running programs. Maybe you can achieve without like going deep into compiler stuff, but it's definitely related to the compilers and can be achieved by it to some extent. Debugging capabilities of the language, which is kinda similar but still probably different reason. Okay, I think we will keep today's stream short. Maybe I will stream today the work on RD, maybe not. I will think, I don't know. But for the compilers, I will finish with it for the day and will continue later with lesson 2. We are a bit behind the schedule because the course already started, the spring semester, and due task is already 5 days after deadline. But luckily we're not enrolled to this course officially, and it's not a big deal. There's also a due for the lesson 2 already, but I hope we will get through those lessons relatively quickly and it won't be too much tasks. Actually, let's take a look at the list of tasks for this one. Yeah, it will be about Brill intermediate language, and it's actually 2 videos for representing programs. Oh, it will take you know, quite some time, and it's written in TypeScript. Holy moly. Okay, it will be a lot of work, I guess. We don't like jump quickly through this lesson. But I hope it will be fun at least. Okay. Thank you everyone for joining today. We will continue tomorrow morning near the same time. I hope you enjoyed, and I will see you in a bit.